Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick.
Hello, I'm Ed.
And, we don't have Champ with us. His family is in town visiting. So, we hope that they're having a good, safe time and, are enjoyable. Good thing is they were outside the range of that tornado that came through North Carolina the other day. So that's a bonus. Last week we talked about preventative maintenance checklist, or PMCS, and their checklist, their variants of. So this week we kind of want to get into the management of preventative maintenance. How do I manage, all this information that's coming back? Because if you think about it, if you're running a shop, say, in the additive manufacturing space, 20, 30, 40, 50, 60 printers, you're going to have a checklist for every single one of those things. You have to come back and catalog it eventually. You have to manage that data. You have to work with that data. And God forbid if you work in a robotic 3D printing environment, where some of these cells will have 3 or 4 checklists just on their own. So, this week we're going to talk about that, the preventative maintenance management side of it, and how to get all that stuff situated. So, Ed, when we talked about the management of preventative maintenance, what do you think?
So, I'm going to kind of cover it from 3 parts. So, I'm not going to cover all 3 parts in this one portion of where I'm talking. So, basically, the first thing you want to do is you want to have a good documentation system. Mm-hmm. Preferably, if you have printed documentation, those things should be scanned and stored. I would prefer that you go to digital, use some type of electronic appliance, like a tablet or a phone or some type of smart device.
And that would, you can use Power App and load it all back into Power BI, and Power BI will do 95% of it for you.
The next thing that I would encourage is that you have transparency. So you should have some way to verify that whatever's been signed off on checklists, that you do some type of audit to verify that what you're putting on the checklist is consistent with things that are on the shop floor or in your print farm. And then lastly, I would set up some type of dashboard. I think a dashboard would be really good because it's real time, and the ownership of that could be enhanced by somebody being able to see real time the fruits of their efforts.
And talking about the audit, the preventative maintenance audit, and I think we can do an entire episode on that particular topic. However, kind of want to touch on it a little bit, is have somebody else do it that's not familiar with it.
So
have somebody take a look at it.
Yeah.
Because the thing is, if it passes the sniff test, then you should be okay. And, do that when you're first setting them up too. Is set up the sniff test. Here, or the 1,000-mile test. Here, can you try this? Take a look at this, let me know if it makes sense. Have on there where you're getting your data from, because you're not pulling facts and figures out the sky. I'm not saying, hey, I need this to be this many millimeters or whatnot, and I don't have any data to back that up, because I'm going to ask you where it came from. And why am I measuring that? Where is that fact and figure originating from?
And that's why I say everyone should invest into Industry 4.0 and a lot of things that you can use. In particular, I would look at, having like a unified namespace. Mm-hmm. I would look at having things like one center of trust, so one center of truth. We know we can say, hey, this is the standard, this is what we have, this is what we're doing, this is how everything should be set up. And then from brownfield to greenfield, those things stay the same, stay consistent. The other thing is by keeping a record, you give yourself the opportunity to project into the future with equipment that you may install later. You can say, well, okay, these are some of the things we found. You can also have a good relationship and have a tie-in with your manufacturers or your suppliers to say, hey, here's the things that we're having problems with. And then that can help those suppliers maybe engineer out some of those things that they didn't think about.
Or they can send you a senior tech.
Yeah.
And that senior tech can look at it.
Yeah.
And also, if you're building checklists and you're talking about the audit trail, or you're talking about the 5I process, 4I principle, or even contacting your suppliers, have a check-in, check-out process. If, I create a new PM, I want to be able to check it in so it can review it, let me know, hey, guess what, this makes sense, and I check it back out and I can use it at that point in time. And have everything dated. Because then you can send, if you're having an issue, for example, with a printer or in a robot, and you're getting things that are just off tolerance, just wackily off tolerance. You tried everything you can, program that thing back to tolerance. You can run a couple of test pieces on it, and guess what's back into tolerance again. You can, as long as you have all that documented in your PM, you can turn around and send that entire PM stack saying, hey, guess what? This is how many times I've noticed this. This is what I've tried. This is what we troubleshooted back to the manufacturer. And they can either send somebody to you to work on it, or at least explain to you how to get out of the current situation you're in. Yeah, it's a little harder when you're like, you can't really go to like Reddit for robot. It's like I can't go to Reddit and say, hey, guess what? I'm having an issue with this ABB robot, or I'm having an issue with this FANUC robot, or I'm having issues with this KUKA robot and this connector. Why is it doing this? Some of them really know. They do have those forums out there, but then again, it goes back to if you have proper documentation, you can explain that of what your problem is.
And then also you can check consistency between the personnel that's doing the PMs. We can verify that who did the PM, when the PM was done, and that the PMs are all being done the same. So basically, one center of competency with the PMs. But the PM should be more than just a checklist.
Yeah.
You should also, like Nick was talking about, you should use routes so that if you have line keepers or you have attendants at the line, that they can do TPMs where they can do things to say, hey, every day they do a check visually, or hey, they're listening, or hey, maybe there's a sound they hadn't heard before, and they were like, hey, that doesn't sound right. Or maybe they even see something in the quality of the part that's coming out on whatever machine. So that's another thing, another part of your documentation. You have to documentate daily. So everything that's done daily, everything that's done weekly, everything that's done quarterly, and everything that's done yearly. And then with those things, by keeping a record, especially if it's digital, you can take that data. So kind of like the oil companies with the down the hole data, you have something that you can do analytics on to say, hey, well, it doesn't make sense to do this PM because we did this PM every month and we never seen it. We didn't see a failure for this particular PM. Right. So maybe the PM shouldn't be done every week. Maybe the PM should be done every 3 months. And then you can check to see if there is some performance degradation over time.
And if you can't afford, and the thing is, here's the best part about that. If you have people in the station, use QR codes. Don't have them have a piece of paper. It's driving nuts. Have a QR code that they can scan with a phone or a TC52 scanner or something like that they've got. And then they can go in there and fill out the survey. That says, hey, I was here at this time, I observed this, I've heard this. This is what's going on. You kind of go through and make sure you've got the daily, hey, this is what I checked, this passed, stuff like that. And if you can't afford Microsoft 365 and its full suite of Power Apps and stuff like that, or Microsoft Word or something like that, you're just starting out. You're using, open source materials. You can use Google Sheets or Google Forms. Create a checklist in Google Forms, have that upload to a Google Sheet, and the Google Sheet will do the analysis for you, or at least graph it for you. It won't be as predictive as what you would get in like Power BI or something, or systems that are pre-programmed for that application. But at least it will give you a starting point to have all your stuff documented. And the thing is documentation helps resale. If you move on to bigger machines and stuff like that, and you have the maintenance documentation, the preventative maintenance documentation on this equipment, it will sell for a higher value, especially if you're using it at the commercial level. Because I don't know about you, but I would not like to buy a piece of equipment that didn't have at least some sort of documentation on it, maintenance documentation.
Yeah, probably wouldn't be wise unless you're the person that's manufacturing that piece of equipment.
Right.
And I would hope that you have some engineering plans and CAD drawings and things of that nature. It's not just putting pieces together. So even in that case, you still would have to have some documentation.
Yeah. Square peg rental.
You know, current capacities, voltages and stuff like that. So I would assume you'd have some type of engineering documentation in place for that. I would say another thing to consider when you're setting up these preventive maintenance programs, say in particular for like when you're doing additive manufacturing, you have to consider. We talked about it before. You have to consider the material,
the consumables,
what you're printing, and the temperatures, because all of those things could have different wear effects on your equipment based on the frequency of what you're doing. So that's another thing with documentation. You would have a way to do that, and then maybe you could set up recipes. Mm-hmm. And I know that, hey, if I'm running ABS for 2 weeks, I know to factor in that I'll have to do this machine will have to be taken offline for maybe a weekend, and we'll do all the necessary maintenance and replace what we need to replace if something wears out. But in particular, you're probably going to change more consumables when you're using ABS at a higher temperature, or some of the materials that are more exotic with different type of fillers in them.
Now, the thing is when we start talking about consumables and stuff like that, it's like if I'm storing my consumables in a special room that is climate controlled, it's humidity controlled, I need to be able to have a PM on that environment.
Yeah.
Checking that environment, make sure all the readings are correct, have all that piped out someplace so I can see what's going on. Because if the humidity is too high, like a filament storage room, your film is toast. Now you gotta dehydrate it all, you gotta knock it all back. I understand that, we start getting these higher end printers and they're encased in canisters that are full of decadent or desiccant and all this other stuff, and, they're inherently dry. Mm-hmm. However, most people starting out and doing that aren't going to be, or people who want to use FDM type of printers aren't going to be in that situation. So, for me, checking the consumable storage, it should be another PM and also something that is recorded. Yeah. Because one missed PM on a consumable storage can lead to a really bad idea. It's like, if you think about it, if you're storing your nozzles in a certain area and you're using copper nozzles or bronze nozzles or whatever, something that's conductive, and if you add electricity to it, it corrodes. Is making sure those nozzles are stored in a dry area. Make sure they're either sealed, individually sealed, and they're away from water or electricity. Because the thing is, you add both of those together, they start to corrode at a high rate. Excuse me. Sorry. Too much black pepper.
Yeah. Excuse me, guys. Another thing that, just to follow up on what Nick was saying, is not only the storage of that, but if we do documentation the way we're supposed to, and we use some of those tools we advised. For example, if we used forms from Google, or we use the 365 suite from Microsoft, those are some things that we can put in place in conjunction with Power BI and do some data analytics. But I think it is important that we touch on like the material that you're using. If you're using that and at that particular time and you're not going to use it, you should have a long-term storage for that material.
Yeah,
I
agree.
I would even suggest maybe getting some type of vacuum seal machine to reseal it after, or if you don't want to do that, like Nick said, some type of container that has a desiccant or something that you can put in there.
Control the room.
Yeah, because I think those things for long term storage, especially if I'm not going to use it for 6 months.
Yeah.
Or if you don't have that capability and you just want to use a room that's climate controlled, I would suggest that you do maybe a small batch of prints, basically like a TPM, where you can do a first part release, and you say, hey, I'm gonna print, maybe 10 benches, calibration square, or temp towers, or whatever you want to do, and then just do your analysis off of your first part release or your master part that you had to verify that you're still in the area that you want to be, as far as the quality that you had when you used the material initially.
And with that, what I would do is also make sure you take pictures of that. If you do a first part test, which is highly recommended, is take a picture of it and throw it into your management suite. And so you can always go back and reference that, and use the 4x4 squares or the measurement sticks, the L things, that you throw it in there and get an accurate measurement on there. I think and the thing is, and you'll know if you have an issue down the road, you fire off another, square, and you see if you've warped something or something's not right. And also with long-term storage and stuff like that, you can also tell if your consumables are walking away a lot faster than you're consuming. So it's a security standpoint. So now you're in control of your own equipment. It's like PM is not just to check to make sure if your stuff's broken or not. Preferably not. Hopefully it's running fine, but it's also to check to make sure that things aren't being stolen. It's like beds, for example. So we start talking about PM of beds, and the management of that is understanding what bed has been printed on and how many times. Throw it in a rack, and so you can check it and stuff like that. See what's going on. And then, also if you're going to invest in the full PM management suite, is database most of this stuff. It can be in an Excel format. It can be in an Access database. It can be in Power BI, but make sure that's piped out to something else. And if you are using paper sheets or something thereof, start scanning them in to like a SharePoint, so you can keep that for your long-term storage. To make sure you keep all that stuff, because the thing is if a customer orders a part and that part is not correct, you're going to go back and you want to look at the equipment. You want to go back and look at all the PM sheets, and this is why you need the management suite of some sort that you can create yourself or whatever. You can go back and check to make sure that all the PMs are done. See what the last calibration looked like, and understand that, okay, cool, maybe it wasn't that, maybe it was the printer, maybe it was a nozzle, maybe it was this, maybe it was that. And you can actually start doing all that. If you don't have any documentation in play and stored, you have no way to do a root cause analysis to tell you what happened.
Yeah.
And then guess what? You lose a customer. You can't say, you'll turn around and blame if somebody turns around and blames the customer because they have a bad STL, or they have a bad CAD drawing that didn't get translated correctly. It could be a perfect CAD, it could be a perfect STL. However, if you turn around and blame the customer because your machine wasn't PM'd correctly, that's on you. And you'll lose that customer because either A, you just lied to them and you didn't tell them what was going on, and say, guess what, we found an issue in our calibration, let me reprint that for you for free. Guess what, you're going to keep that customer longer.
Yeah.
Almost guaranteed.
And sorry guys, I do think, like what Nick's saying, is it doesn't, if you're invested in the equipment, you should invest into the tools that you need to make sure that the equipment is, first of all, that is being maintained. Secondly, that is operating the way that you originally designed it or originally spec'd it out to perform at. And then I would say, lastly, you want to be able to learn lessons from using those particular type that particular type of equipment.
Mm-hmm.
I mean, it makes no sense to invest into a printer and say the bed goes out in 2 months,
Right.
because either you failed to do regular preventive maintenance, or you didn't have the settings right, or you had a setting that you just set, and that setting basically was in you concentrate everything in the center of the bed.
Mm-hmm.
I mean, over time, if that's where
Center
you
starts to
heat,
warp.
I mean, so you have to think about, you have to consider all those things.
Yeah. And it's, a lot of stuff in the center, forget it. It's just, also if you have a bigger corporation or a bigger enterprise that you're working on, where more than one or two people at this point, is, make sure you have somebody on staff that's what they look at. That they look at the trend analysis of your prints. They look at the trend analysis of your stuff. And if you now the thing is, if you make the same part over and over and over and over and over again, keep a master calibration copy nearby. Mark it as such so you don't give it away. Mark on the back, calibration. So, and I know that's something else we could probably talk about eventually, is calibration. I calibrate the stuff. But it's making sure that you have a calibration copy nearby, that when you're doing your PMs, you can take a part off and take a look. Is this correct? Is this not correct? Is this right? Is this not right? Does this match?
Yep. And if you, like you said, if you have that record, you have that record that you can take and say compare to, hey, well, 3 years ago we purchased this particular type of printer and that was good for our application then, and that preventive maintenance program was well thought out for that. But however, now we've graduated to a different type of printer, or we've graduated to maybe we're doing more than just casual printing. Maybe we're doing more robust prints that require, more time. Maybe our print time before was 6 hours. Now we're looking at printing things that's 24 hours. That's one of the things you have to consider when you run a machine for 24 hours.
You're right.
Or if you're running a machine for 48 hours. Some prints could take up to a week,
exactly.
Depending on the complexity of the print. And it doesn't matter if it's FDM or if it's one of the other type of systems where we're using resin.
Yeah.
But you have to consider those things when you, maybe in the beginning, this is what we purchased, and this was the item or the part we were printing at that time. However, now we've graduated to more of a commercial or an industrial footprint. Well, the hobbyist printer is not going to be able to compete with a commercial or industrial printer.
Right. And the thing is with preventive maintenance, ignorance is not bliss. It's, the unknowing should not be the unwilling. And you should always be wanting to learn just that one step more. That's the thing that we preach, on this podcast a lot is always keep learning. And keep moving, keep learning, keep taking the next step. And the thing is, so if you have that information on hand, ignorance is not bliss. You should not be blind to what is going on inside your operation. It should be in front of you 100% of the time, saying this is what's going on. If you do that and you work and you say you run a print farm by yourself, you can go home. You can look at all your data, say, okay, cool, this is what's going to happen tonight, and be pretty confident that guess what, that's what's going to happen the next 24 to 48 hours. But saying I don't know how that happened, I don't think that's an excuse these days. I think the ability to have the technology at your fingertips, calibration squares, gauges, all of that software. I don't think the unknowing is not like a formidable excuse anymore. I just don't think it is.
And then, like even automobiles, just as a comparison, it's a little bit different, but it is a machine. Even with the automobile, they say after so many miles or after so much usage, things are required that must be done. It's the same thing with the printer. What you'll learn is you'll figure out the routine or how long it takes for something to break.
Right.
And with that information, you can take that information and make a better decision the next time you have to purchase a new piece of equipment. You can say, well, hey, we know that this machine is good for running, moderate cycles. It's not a heavy duty cycle machine. So either I spread the load across several moderate load equipment, or I just pay the money to have something that's more robust, more industrial. Yes, I have to probably pay more attention to the preventive maintenance on this because it's going to be a little bit heavier equipment, maybe some chains, and maybe you have to do more due diligence, manual cleanings and things of that nature, lubrication. But it probably can do the job faster, and it can handle the heavier loads if that's something that's required.
Right. And the thing is as you start getting into the fact that we're getting into industrial automation of additive manufacturing, which is the use, and I think that's something that you and me should cover in a totally different podcast, I think, is the use of like KUKA robots, ABB robots, FANUC robots, in additive manufacturing. You really don't see a whole lot of Mitsubishi robots getting involved in additive manufacturing yet, because I don't think they have the parts available for them yet. At least not here in the U.S. But a lot of times now, what is ABB really specializes in a lot of the additive manufacturing stuff now. I think FANUC was really getting started, and me and John saw a couple people at Rapid using KUKAs. They're not using heavy lift arms, but they're using typical arms. However, but that's automotive. That's the automotive manufacturing world getting involved in additive manufacturing. So you're starting to get industrial automation in additive manufacturing. So with that means your PM environment is going to explode. Because now you're dealing with, okay, cool, does my lockout tagout work? Is my PLC online? Or is the environment that is running Robot OS, online and powering the robot correctly? Does robot see its commands? Does it understood? Is my fence in one place? The thing is once you start thinking about, when you start going outside the box, because the thing is you're really not even talking about frames when you're talking about the, tabletop 3D printers. Yes, if you have doors and stuff like that, okay, does the door seal? Yes, that's one. Okay, when you start dealing in, industrial automation inside 3D printers, you start dealing with, okay, is the gate locked? Does lockout tagout work efficiently? Is there any issues and is there any breaches inside my fence surround? Around the robot? Because now you're dealing with a piece of equipment that can easily, without thinking about it, kill somebody. And that still needs to be documented the same way you would document a repair.
And what you may see in the future is you may see hybrid environments where you see a cobot. So basically, you may have lower duty robots that will be doing part handling. So you could probably have a process where a human would have to go over and maybe do something with the flashing if you're talking an FDM machine. Then the robot can do the same thing like what they do with robots when they're pulling cast parts or pulling out parts that's coming out of a foundry after they've cooled, and they clean the deburr and so forth. So you may see more of that in the future. With when I say a cobot, I basically mean a robot working with a 3D printer. You may also see more things where it may be a conveyor system. You may see more conveyor systems where a conveyor system and some pneumatics with some actuators or cylinders push a part off to a conveyor. The conveyor deliver the parts at the end of the line to the robot. The robot picks in place, put them in the do whatever finishing and place the parts where they need to be. Maybe you have some vision system scanning.
Yeah.
So you can possibly have a lot more things added once we get to the point where we get a little more maturity in the 3D printer environment for processes that are time sensitive.
Yeah, and a lot of times you're talking about big prints. You're talking about like the Kuga arms that have the adapters on the end that are doing 3D printing, that are printing FDM by large spools of filament, right? And stuff like that. That again is something that needs to be watched. It's don't underestimate the power of automation. Play with it. I like to tell people that when it comes down to industrial automation is accepted, it's not going anywhere anytime soon. Work it into your processes. If you don't think you can't afford it, I guarantee you can afford it a lot faster than you think you can. We found, Fanuc robots. I think it was a couple weeks ago. We found used Fanuc robots that you just have to probably refurbish, which is just cleaning them up for what, $3,500, $4,500, something like that. And you have the small 1919s or something like that from Kuka, the pick and place robots that you can find for sub 40. Some places you can definitely get into it. It's definitely available. It's definitely there. That type of stuff is stuff that you need to absorb. However, don't forget to do the PM. Do your management on there. Understand that this is what has to happen. And also, if you buy a piece of equipment and that piece of equipment's en route, start building the PM process for it already. Look through documentation. When it comes in, scan the serial number or whatever you can into your management system, and then tie all of the possible inspections to that piece of equipment. Then every single piece of equipment has its own jacking.
Yeah, asset management is very important.
Yeah.
Not just for PMs, but for tax purposes also.
Yeah, how much it's used.
That's something that you really want to do in the beginning. So you would probably have your engineering team do a little bit of homework before you just go buy a piece of equipment. Unfortunately, sometimes in the industry we treat equipment like going to buy a new hand drill. Hey, well that's a DeWalt, and that's one of the best ones on the market. It may be, but you also have to look at how is that applicable to my application? What are the benefits? What are the pros, the cons, and so forth? So you want to do a little bit of homework, and it's not always a good thing to just cookie cutter. Yeah. It's okay to copy good things, but you want to also make sure that the data is valid. And it all goes back to documentation. You have to documentate the whole process. And it should be the same way like when you're doing an analysis on software. So you did development and you're checking the software. You should do the exact same thing when you're buying hardware.
Oh yeah.
You should do a vetting process where you verify, hey, this is what we want, and it should be campaigns. And always through those campaigns, whether you want to use Agile or whatever other type of methods you want to use, you want to do the same thing with equipment. Hey, I want to check, and verify that when I get this equipment, I verified what I needed from it. It's applicable to my application. Now, it makes sense for me to already have my preventive maintenance program in place because I can take some of the documentation from the manufacturer.
And the thing is, if you're on good relationships with your manufacturer, go fly out to their ask them if you can fly out to their location and go take a look, or ask them, hey, who has some of your gear on site that we can use, that we can talk to.
That's better.
To see what's going on. Even if it's a competitor or it's on a forum someplace. Hey, what do you guys think about this? How do you guys maintain them? Some people you're going to get out there that are just complete, hate to say it, jackasses.
Yeah.
And, it's like any other regular printer. Yeah. Or it's like any other regular robot. No, two things are not the same. Ed used the analogy about DeWalt. Well, the thing is if your team's, trained on Makita and not trained on DeWalt, and you buy DeWalt's, and everybody's not confused because everybody's got the wrong batteries. that's one thing. It's making sure your team's up to date on training to, handle the.
And that's an important part of the preventive maintenance. If you buy equipment, even though it may be the better choice, but it's too complicated for the personnel you have in place to do the preventive maintenance, and they do not understand or you do not properly train, then you have basically just voided your PM program.
Yep.
So you should keep in mind the level of technical expertise you have on site when you're buying equipment. Or you should have a package that you put in some things that can do error handling. Put in some things that, okay, I know this is something that humans are probably going to have a problem with. Have visual management in place. Make solid procedures. You want to do all of those things in the beginning, in the green field.
And y'all, me and Ed talk from a level of where there's experience there. We've been in a situation of where we've had people purchase equipment that probably shouldn't have purchased that equipment, and no one's trained on it, and it eventually goes to crap. Or then they just blame everybody their grandmother, thinking that they don't know what they're talking about. So we've seen that, and the one thing we don't want to do is people fall into that same trap. It's, understand that, equipment requires training. Even if it's, hey, I'm buying this piece of equipment, it's the biggest piece of equipment I've bought. Can I please send people to the manufacturer for training, see if they have an on-site training program, or if when they send out their senior tech to install it, will they stay with you for a couple days to figure and walk through, how do I PM this thing? Walk me through training on how to use it. How do I PM it? How do I work on it? How do I do this? And start a buy-off procedure where you have a white, yellow, and green buy-off, and make sure that the understanding of your PM process is in your green buy-off.
Yep.
That you don't take control of that equipment from the manufacturer until after your team knows how to PM it.
Right. Well, I'll give you a perfect example of what I mean by, and we're going to keep it in the perspective of FDM printers, desktop. I can get someone an ender that's already ready to go, other than doing an alignment, assembly, an alignment, and then putting your program into your printer. Or I can give someone, hey, go buy these parts. And okay, now we don't want to just do an ender. We want to take this ender and turn it into something else.
Right.
So now I've just created a level of complexity that's unnecessary. I can either give somebody an off-the-shelf solution, or I can give somebody, hey, I'm gonna give you a partial solution, and then learn as you go. To me, this is always a bad idea. It's better to spend the money up front.
If you do in-house builds like borons and stuff like that, if you build those things out and your engineering department builds those, for your team members, just train them on it. Have them in a test lab, have them work on it, see how it works. Have them there as part of the build out to understand how this thing works. And then turn them loose on it. It's not that hard. It's really not. But, the thing is we hear day in, day out that the PM process has failed. And it will. It'll fail somebody. I guarantee it. And then you're going to end up with situations that you shouldn't be in. But the thing is we hope that if you have a PM management system in place, the pain will be less likely to occur, we'll say. So, I think we've came to the end, I think. I know we had a couple of topics we want to talk about offline. We're on a different episode that we'll be talking about, so y'all are purview to that conversation. Mainly, we started getting into industrial automation and stuff like that, so a little fun there. So, I want to say thank you to every single one of you. We just crossed 1,800 listeners. We're at 1,804 total listeners. And, I'm looking at the stats. In the last 30 days, we've had 101 downloads. 27 in the last 7 days. y'all killing it, you know, and we highly appreciate it. You know, go check a look at, you know, Vulcan R 3D, you know, some of the shirts we got on there. Well, I promise there's more coming. We'll get around to it. Go take a look at the YouTube channel, you know, Vulcan R Technology Solutions. Some of y'all might be listening to the podcast on YouTube. Do me a favor, hit the subscribe button. It's one click. I promise you it's not that hard. You know, also, if you really want to see something funny, go over to, you know, a YouTube channel called Vulcan RA Eats. That's where me and Ed and possibly John are be doing some nutty things as far as, you know, going to grab something to eat, you know, and talking about it, stuff like that. So, you know, y'all get more candid version of us at that point. So, go take a look at that. You know, we wouldn't be here if it wasn't for y'all. We highly appreciate it. You know, thank you. And, you know, hopefully one day we can get together and do something in person. So, all right, you know, we'll turn it over to Ed. Y'all have a good night.
Yeah, we appreciate all of the support. We still encourage everybody that's listening, if they have any suggestions or if there's something we can do better or there's something that we're totally wrong on, please leave us feedback. We would like to give you good content. We like teaching. We like talking about technology. And like Nick said, if it wasn't for you guys, we wouldn't be here. So thank you very much.
There you go. Y'all have a good one.
That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoy the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcan R Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. We'll see you later.